Hello students, so today we are going to start a new topic called center of gravity. You know the meaning of center. Now gravity stands for gravitational force. Gravity stands for gravitational force. So center of gravity means we can consider a body to be made up of various small particles, and each particle is having its mass m1, m2, m3 and so on. So I will draw just a minute. See, this is a body. Okay, it is made up of various masses m1, m2, m3, m4, m5, m6, so various ones. So to each mass, Earth is attracting downwards. So this is W1, W2, W2, W3, W4 and so on. Now the size of this body is very small compared to size of the Earth. So all these forces would be vertically down, so they will be parallel to each other. So their addition means we have to do the addition of all these forces which are in the same direction. So I will get one answer. That answer is called weight of the body. So what is W? Weight of the body W is equal to W1 plus W2 plus W3 plus W4 and so on. So it means that instead of considering the full body, I can consider a particle of weight, this W, of weight W, which is equal to sum of the weights of all the particles. Now, where does this W act? Which is that point? That point has to be at center. But how to get that center point? How we define that center point? So this point is such that if I take the moments of all these weights about that point, I should get 0. So the point is such that so center of gravity is a point such that if we take moment of weights of all particles of the body, I should get 0. So you can read this definition. Center of gravity of a body is the point about which algebraic sum of moments of all weights of particle constituting the body is 0. So if I know center of gravity, it means, so this is center of gravity. So this point I am telling is CG, center of gravity. So I can consider only one particle whose weight is W and it is acting at this point. I need not consider the full body, I will get the same results. So for doing analysis with such large bodies, it is better to consider the center of gravity and the point center of gravity where the full weight of the body is acting. So this is the concept of center of gravity. Now center of gravity of regular objects like a rod. There is a rod. You know what is a rod, isn't it? This is a rod. So this rod will have such a central axis. So the line which is passing through the center of the two diameters of the two ends. If I join, that is the axis of the rod. So the midpoint of that axis is the center of gravity. So center of gravity is always the central point, midpoint of axis of rod. If you are taking a circular ring, then it is center of the ring. This is a circular ring. So center of the ring is here. So this is center of gravity. So center of gravity need not be a point on the body. Like in case of this ring, center of gravity is at the center of the ring, which is not a point on the body. If there is a circular disc like a coin, so what do? You take center of the diameters of the two circles and join the midpoint of that would be the center of gravity of circular disc. Similarly, all center of gravity of various bodies are given. Solid or hollow cylinder will be midpoint on the axis. Solid cone would be, if this you have to learn, height h4 from the base. So, if this is the cone, so this is the central axis. So, height, so this is h upon 4. This distance is h upon 4. If it is hollow cone, it is h upon 3. Parallelogram, square, it is the rhombus, it is the point of intersection of diagonals. Now, how to know the center of gravity of an irregular lamina like which is shown here? So, to get center of gravity of this, we will have to carry out a simple experiment. I have drilled 3 holes, A, B and C, and I have now taken a nail and passing through B, I fixed it on the wall so that the lamina is free to rotate about this hole B. Now I have taken a plumb line. Plumb line means it is a long string with a heavy weight attached at the bottom. So that also is fixed on the nail. So after swinging, this will come to rest in a vertical position. Once it comes to rest, you draw the line along the plumb line. So I got this. Similarly, I got the lines from A and lines from C. So they are intersecting at a point. That point is center of gravity, which is denoted by G. So this is my center of gravity. Where so this is how we can get center of gravity of irregular bodies. Now, from here also you can see that the 3 lines are concurrent. Even if you have drawn 2 lines, they will intersect, that is the point. But if you draw the 3rd line, it will verify yes, that there are 2 lines are correct. So if there is any body, take 3 points, suspend them to 3 points, draw plumb lines where they intersect, that is the point of center of gravity. Okay. Now, center of gravity has got various importance. Like first, if we take this point, center of gravity, then what does it donate? It shows that as if instead of this full body, I can consider only this one particle of weight capital W. So in case you want to balance this rod, you want to hold this rod, you can take even a small nail and put below center of gravity vertically, it will be able to balance it. Because center of gravity means full weight is acting there, now the balancing that weight. Okay. Now, center of gravity, as I told you, need not be a point on the body, like a ring I told you. Even you can take L-shaped body. Suppose this is an L-shaped body. So center of gravity need not be a point here. The point can be somewhere here. So center of gravity need not be a point on the body. Okay. Now the center of gravity, position of center of gravity also tells us about the stability of the body. Now that I will explain to you in the next slide. Now you see what do we mean by stability. You take any body, take some bottle, keep it vertical. If you give a slight tilt, it will come back to its original position. But if you tilt it more, it will fall down. So the body which does not fall down by slight tilting is said to be stable, and the body which falls down with tilting is considered to be unstable. So, and if a body remains in the same position, there is no change, then we say it is a neutral body. Like if you take a cylinder, and keep it horizontal on the ground, like this is cylinder. In the center is the axis, so this axis is parallel to the ground. Now if you move the cylinder, rotate the cylinder here or here, it will remain in the same position, similar position. So this is a neutral equilibrium. But now to take a cone. Now this is a cone I have taken. If I take a cone, you give a slight tilt. This is a cone. To give a slight tilt, it will come back to its original position. So this cone is in stable equilibrium. But if I keep this cone in a reverse manner, so the tip touches the ground, or here there is small flat surface, this is stable, this is now in equilibrium, it is not following. But if as soon as I give a slight tilt, it will fall down. So this is in unstable equilibrium. So this is a case of stable equilibrium. This is stable equilibrium. This is neutral equilibrium, and this is unstable equilibrium. Is it all right? So when we are giving a slight tilt, if the body falls down, it is an unstable equilibrium. If slight displacement, body does not fall down but come back to original position when displacement is removed, it is in stable equilibrium. And if the body remains in a similar manner, it is called neutral equilibrium. Now, how to know that which body is more stable and whether it is stable or unstable? So for that I have drawn a table here. Stable equilibrium, when I am giving a slight tilt, the central of gravity will remain within the base and central gravity is raised. So if this body, if I am giving it a slight tilt, its center of gravity will remain within this base and its height will increase. See, this is suppose this was the original cone. Now I have given it a slight tilt. So when I am giving a slight tilt, so this will go up. The body will become like this. So here the center of gravity was here, here the center of gravity is here. So there is a raise, but still the center, if you draw a vertical, it is within the base. So if the center of gravity remains within the base and height gets and center of gravity gets raised, it is unstable. But now to take this case, unstable. So if I give a slight tilt, this will become like this. So the center of gravity is here. So it is outside this base. And its height is getting lowered. This height, his center of gravity was here, now the height becomes here. So these are the characteristics of, and in neutral body the height will remain same. So it will be within the base, height will remain same. So even if you remove the force, it will remain in the same position. It will not, because the positions are identical, similar. So this is how the stability of a body relates to equilibrium. So these are called three states of equilibrium: stable, unstable, neutral. Now in case you are interested in increasing the stability of the body, then there are two methods. You increase the width of the base, or so that when you increase the width of the base, the center of gravity will be within the base, it will not fall down. Or you lower the height of center of gravity. How you can lower the height of center of gravity? Means your bottom portion should contain high density materials and upper should be of light density, so center of gravity will get lowered. Like suppose there is an empty cylinder. This is an empty cylinder. Okay, this is an empty cylinder. Now, if I give a slight tilt or somewhat more tilt, it may fall down. But if I fill the lower portion with water, so fill the lower portion with water, so now center of gravity has got lowered. As center of gravity has got lowered, now its stability has increased. If you give the tilt, it will not fall. That is why all the vessels, they are broader at the bottom. Cooking vessels, they are normally like this, they are broader at the bottom. So I explained to you that to have maximum stability, the center of gravity should be as low as possible and base should be as wide as possible. So let us try to see how we are use this concepts in our day-to-day certain examples. So that I have given in the form of give reasons. So the first point is, a ship is loaded heavily near the bottom. Now you see, if the ship is loaded heavily near the bottom, then its center of gravity would be near the bottom, would not be at a higher height. So the ship would be more stable. So to increase the stability of the ship, so that due to waves, when the ship is tilting on either side, it should not become unstable and get sunk. Second, same for ship. Passengers are not allowed to stand when ship is sailing, because if you stand, the center of gravity would get lifted up. So that center of gravity should not be up and make the ship unstable. Passengers are not allowed to stand. So the reasons are same. Now let us see next one. It is easier to knock down a person when he is standing on one leg than when he is standing on both the legs. If a person is standing on one leg, then the base is small compared to when he is standing on both the legs. So when the base is of wide, then the stability is more. So to increase the stability, we are more stable when we are standing on both the legs. Next, a man carrying bucket of water in one hand stretches his other hand outward. Now when a person is carrying bucket of water, then center of gravity would get shifted towards that direction. Now so that when it gets shifted to that direction, means he is now near the edge of the base. So that the center of gravity comes back to the middle, he stretches the other hand, and with this the center of gravity is somewhere in the middle of the base. So is more stable, is more comfortable. For him to topple down would be less. Next, the tightrope walker usually carries a long pole having weight at its end. Now, when a person is carrying a long pole and weight at its end, so the long pole will get tilted down, or these ends will come down. A person is holding in his middle, in his hand. So the person is holding here and the weights are down. So center of gravity of this rope will come down. As center of gravity comes down, the center of gravity of the person along with this long pole will also become down. So when the center of gravity gets lowered, he is more stable. Is it alright? Now we'll go to one more. In a double-decker bus, so bus is having, so that person can sit in the lower deck as well as in the upper deck. Luggage compartment is always kept at the lower deck so that center of gravity of the bus would be at a lower height, because heavy things should be kept bottom, as we discussed that a ship is carrying heavy things at the bottom. For the same reason, passengers, suppose there are 10 passengers who have come, we will say that they request them to sit in the lower deck so that the weight is at the lower. Once the lower deck becomes more than 50% or 70% full, then we can tell other passengers to go in the upper deck. So these are some of the applications of the concept that we have learnt in center of gravity. This is very important. I hope you have understood. If you like this presentation, please subscribe to the channel and press the like button. Thank you.